Lay's potato chips. Bet you can't eat just one.
A slogan that's become legendary, tied to one of the most irresistible snacks on the planet, Lay's potato chips. And honestly, once you open the bag, you'll get it. These thin, golden crisp slices aren't just a snack. They've become part of daily routines for millions. And yeah, even a full-blown addiction for some. In this video, we're taking you inside the Frito-Lay factory to uncover how these iconic bags of Lay's potato chips are made. Trust us, it's a crunchy journey you won't want to miss. This is one of PepsiCo's largest and most advanced factories in Europe, and it's where millions of bags of Lay's are made, the same ones we casually snack on every day. With a jaw-dropping output of around 4 tons of potato chips per hour, this facility processes over 750 tons of raw potatoes daily, running more than 4 production lines non-stop to keep the crispy goodness coming. PepsiCo is now one of the world's biggest potato buyers, sourcing up to 240,000 tons annually. The journey begins in vast potato fields, where harvest season is in full swing. Since potatoes grow underground, farmers use a specialized digging machine. This powerful rig can reach up to 10 inches deep, cleanly lifting entire plants from the soil, roots, rocks, dirt, and all. Everything gets loaded onto a vibrating conveyor screen that shakes off excess soil while sorting through up to 40,000 potatoes per minute. From there, the potatoes are transferred directly into trucks driving alongside the harvester. This synchronized setup keeps the operation smooth, steady, and interruption-free. Once full, the trucks head straight to a nearby storage hub, a massive facility purpose-built to handle hundreds of tons of fresh potatoes every single day. Next, the potatoes are funneled into an optical sorter, massive machines running at full throttle, all with one critical mission: finding the perfect spuds. Fresh, firm potatoes ride along a conveyor belt, passing through a sophisticated scanning system. Here, high-precision sensors inspect each potato in detail, analyzing its size, shape, and color with incredible accuracy. Meanwhile, nimble pneumatic robotic arms spring into action, swiftly removing clumps of dirt that got mixed in with the potatoes. They move so fast, it's nearly impossible to follow with the naked eye. Finally, any potatoes that don't make the cut, those that are bruised, diseased, or just too small, are instantly ejected from the line. Only the top-tier spuds move on to cold storage. Freshly pulled from the earth and still dusted with soil, the potatoes are gently placed onto a conveyor belt and moved into massive wooden crates. From there, they continue their journey into a cold storage facility, with enough room to hold a staggering 40 million potatoes at once. Here, the spuds rest anywhere from a few weeks to several months, depending on production schedules. And when the Frito-Lay factory calls for a new batch, forklifts get to work, hauling the crates out of storage and onto a conveyor leading straight to the washing station. This is the first step in getting the potatoes camera ready, mainly to scrub off any dirt and debris, because Frito-Lay is paying for potatoes, not the soil they came with. Next up, a team of workers performs a final manual inspection, weeding out any stragglers that don't meet quality standards. Clean, shiny, and prepped for glory, the potatoes roll onto the belt one last time, this time into the waiting containers at the back of a truck. And from here, things speed up fast. In less than 24 hours, these fresh spuds will arrive at the plant and become Lay's classic. When a truckload of potatoes arrives at the factory gate, the entire vehicle is lifted onto a massive hydraulic platform, then slowly tilted forward at about a 30-degree angle. And then, like a tidal wave of tubers, thousands of potatoes come tumbling down onto the conveyor belt below. From there, the potatoes are routed to the incoming quality control area, where random samples are pulled for starch content testing. Even though the spuds were already washed once back at the farm, the entire load is sent through an industrial washing system all over again. It's not just about cleanliness, it's also about protecting the factory's precision equipment. Just one tiny speck of leftover dirt could scratch a blade or mess with the peeling machines and other delicate systems downstream. This high-powered rinse uses a combination of intense water jets, industrial brushes, and a swirling water vortex to make sure each potato comes out spotless. This system is no slouch. It can wash up to 6 million potatoes a day. Next, the potatoes enter one of 6 large-scale peelers, each lined with a rough, abrasive material on the inside. As the machine spins, the potatoes tumble and roll, rubbing against the gritty surface, which gently scrapes off the skin. At the same time, high-pressure water jets spray the spinning spuds, washing away the loosened peels. Once peeled, the potatoes pass through an advanced camera system that scans each one in real time. In just a split second, these cameras can detect signs of rot or visual defects, and if something's off, a mechanical finger shoots a targeted puff of air to eject the faulty potato from the stream for other uses. The good ones move on along a specialized conveyor system. Here, an automated sorter separates the crop by size. Only standard-sized potatoes fall through the slots for further processing, while oversized ones are diverted to a cutting station where they're halved before continuing down the line. To make sure nothing slips through the cracks, workers are stationed along the conveyor for one last round of human inspection. They keep a sharp eye out for damaged, bruised, or partially peeled potatoes that may have escaped the machines. If they spot any spuds that are still too large, they'll slice them in half right there on the spot. Next, the potatoes are loaded onto a conveyor and dropped into a rotating drum slicer. Inside, powerful centrifugal force flings each potato outward, pressing it against razor-sharp blades waiting at the perimeter. In a flash, each spud is precisely sliced into 35 uniform chips, each one exactly 0.06 inches thick, the perfect cut for a Lay's chip before it hits the fryer. Right after slicing, quality control technicians continuously check the thickness of the chips. Even the slightest variation can ruin the texture. Too thick, and the chip turns out flat and heavy. Too thin, and it curls or folds unevenly. The goal? A perfectly even saddle-shaped curve. That signature Lay's look. Depending on the product line, the slicing blades are switched out. Lay's Classic uses straight blades for that smooth, traditional cut. Lay's Wavy or Ruffles, on the other hand, use serrated blades to create bold, rippled edges that not only look great, but also add an extra crunch. Once sliced, the chips drop into a fast-moving stream of water that carries them straight to the washing station. There, they tumble through a spinning drum and go through multiple rinse cycles. First a soak, then a high-pressure spray from above, followed by a second water bath and another round of jets. All of this is designed to wash off surface starch. If left behind, the starch would cause the chips to stick together during frying. Next, the potato slices are dried and transferred to the fryer. They're cooked in a hot blend of sunflower oil. The thin slices are dropped into a massive continuous fryer over 40 feet long, where they're fully submerged in a bubbling mix of sunflower, canola, and vegetable oils. The temperature hovers around 350 degrees Fahrenheit, and the chips fry for roughly 3 minutes. But both time and temperature are adjustable, fine-tuned based on each batch's starch and moisture levels, which are carefully measured using a simple but effective test: how the slices float in the oil. As the chips fry, steam escapes from inside the slices, and the evaporated water is replaced by oil. That's why oil needs to be constantly replenished during the process. But Lay's doesn't just pour in oil randomly. They've got a secret formula, a consistent 50-50 blend of fresh oil and used oil. If the oil is all new, the chips soak up too much of it and end up overly greasy. If it's all used, they turn too dark and lose that fresh, clean flavor. When the chips reach that perfect golden color, crispy, aromatic, and just right, they're lifted out of the fryer. And if you notice everything on the line gently vibrating, that's completely intentional. Because Lay's Classic chips are ultra-thin and fragile, the entire system, from conveyors to chutes to transfer points, is designed to shake gently, just enough to move the chips forward without cracking them. If they used regular rotating belts like they do with raw potatoes, all you'd get in the bag would be a pile of crumbs. And nobody's paying for a bag of potato dust. Next, the chips pass through a state-of-the-art optical sorter that scans over 400 slices per second. This machine acts like a hypersensitive pair of eyes, constantly on the lookout for brown spots, burnt edges, or any surface defects. If a chip doesn't meet the standard, the machine responds instantly, firing a pinpoint jet of air, accurate down to the millimeter, to blow that slice right out of the product stream and into a separate reject tray. Thanks to this lightning-fast inspection step, when you open a bag of Lay's, you're almost guaranteed to find perfectly golden, crispy, intact chips, at least while they're still inside the factory. Right after leaving the fryer, The golden, crispy chips get a light dusting of salt to enhance their basic flavor. But the real magic, the signature Lay's taste, happens in the next step: seasoning. Natural spice blends like chili, black pepper, and herbs are funneled through a dispensing tube inside a giant rotating drum. As the drum spins, the seasonings are evenly distributed, coating both sides of each chip in a thin, flavorful layer. Just a few spins in this specialized mixing barrel are enough to ensure every chip is perfectly seasoned from edge to edge. And since the chips are still hot at this stage, the seasoning sticks like a charm. At this point, random batches are pulled for quality checks before packaging. Inspectors test everything from crunch and flavor to color and seasoning coverage, making sure every bite lives up to Lay's standards. After seasoning, the chips are carried upward by a bucket conveyor to the upper level, where a high-speed weighing system with 120 heads gets to work. It calculates the optimal combination of chips from different trays to hit the exact target weight for each bag. Whether it's a 1-ounce snack size or a 13-ounce party pack, every portion is measured down to the chip. Finally, the chips are sent down to the packaging machines on the ground floor. Once the bag is filled, the machine flushes it with nitrogen gas, replacing the oxygen to help keep the chips from going stale too quickly. Then, the bag is heat-sealed shut. That nitrogen also creates the signature air pocket in every Lay's bag. It's not just for show. It acts as a cushion to protect the delicate chips during shipping. The finished bags are then neatly packed into cardboard boxes and sent off to the palletizing area. There, the boxes are stacked onto large pallets and tightly wrapped in durable plastic film to keep everything secure and stable during transport. And then comes the final step. The fully loaded pallets are lifted onto trucks, ready to roll out and deliver crispy, golden snacks to Lay's fans all over the world. Unlike a lot of popular potato-based snacks, Doritos are made mainly from corn flour. That's what gives each chip its signature crunch and that bold, concentrated flavor in every bite. To keep up with massive production demand, Doritos factories rely on an enormous supply of corn grown across huge open farmland. Every year, agricultural producers grow up to 100 million pounds of corn just to supply Doritos production alone. Corn goes through a growing cycle that lasts about 3 to 4 months, depending on the variety. Each corn plant stands roughly 10 to 12 feet tall and typically produces only 1 or 2 ears, but each ear can hold up to 800 hard, golden kernels. Those kernels are exactly what factories need for grain processing. When corn is ready to harvest, the plants can look almost dead from the outside, dry and brittle. But that's actually the ideal condition. If farmers harvest too early while the plants are still moist, the kernels can mold and spoil during storage. The corn needs to be fully dried to stay stable and high quality later on. Harvest season usually starts in mid-August and runs through mid-October. That's when a combine harvester moves into the fields, cutting down the stalks, separating the ears from the plant, and then stripping the kernels off the cob. The machine runs continuously and can collect up to 50 tons of corn kernels per day. Its header moves row by row, pulling the plants in and processing them inside, separating kernels from stalks, leaves, and cobs. Only the kernels are saved, lifted into a large storage bin on top of the combine. Once that bin fills up, the combine has to stop and unload. If it doesn't empty in time, corn can overflow and spill back onto the field. That's when a specialized gravity flow wagon pulls alongside to receive the corn. The kernels move from the combine's rear bin through an auger and pour into the wagon's container. After leaving the fields, trucks loaded to the brim with corn kernels line up and head straight for the plant. There, the corn is transferred into storage. Huge silos with a capacity of up to 60 tons. Each individual silo can hold around 8 tons of corn, keeping a deep reserve of raw material available year-round. Once a silo is filled, a smart control system constantly monitors moisture at multiple points inside. Based on real-time weather conditions, the system automatically adjusts. If the outside air is humid or there's light rain, fans kick on to keep the interior environment dry. The goal is to hold moisture steady between 13.5% and 14.5%, the sweet spot that prevents mold and protects quality. Stored under these conditions, the corn can stay in the silo for 4 to 5 years, while still keeping its freshness and original quality. The first step in making Doritos is selecting and cleaning the raw ingredient, high-quality corn kernels. Once the corn enters processing, it's carried through piping into a series of modern sorting machines that grade it by size, shape, color, and overall cleanliness. Foreign material, like leftover pieces of cob, gets blown out using a powerful air system. Vibrating screens also sift everything carefully, removing even tiny fragments of glass in case any accidentally made it in during harvesting. During sorting, small, lightweight, or off-spec kernels are removed as well. Corn that isn't good enough for human use is sent to a gravity separator and then moved into a separate storage area to be used as livestock feed. The kernels that meet quality standards keep moving forward and are sampled for testing, checking size, freshness, and hardness to keep flavor consistent from batch to batch. After the corn has been thoroughly cleaned, the kernels are fed into large cooking tanks equipped with modern agitation systems. Here, they're heated to just under boiling in a specialized process known as nixtamalization. Each tank can hold about 300 kilograms of corn along with 200 liters of water, and the mixture is kept at around 97 degrees Celsius for about 4 minutes. The main goal of this step is to soften the kernels and break down their internal structure, creating a smooth, uniform base, a key foundation for the crispy Doritos chips that come later. Once the corn reaches the right softness, the heat is shut off, and the kernels are left to soak in that same cooking solution for about 10 hours, with the water level carefully controlled by sensor gauges. During the soak, water continues to penetrate each kernel, allowing it to absorb moisture and reach the ideal hydration level. When soaking is complete, the tank is drained. At this point, a layer of residue forms on the surface. This is the loosened outer skin of the corn, separated during cooking. A pumping system underneath then pushes the hydrated kernels through piping to the next stage. Next, a separator removes excess water, leaving the softened corn at about 45% moisture. With the outer skin now fully loosened, pumps send the corn into a washer. Under strong water jets and rotating screening drums, any remaining skin is stripped away completely, leaving clean, fully prepared corn kernels. After washing, the corn kernels are fed into a holding hopper, where a screw conveyor pushes them into the space between 2 grinding stones made from aluminum oxide. This is where milling begins. The stones spin at about 750 RPM, breaking the corn down into masa, a smooth, pliable, uniform corn dough. During this step, the plant blends in about 20% white corn, which has a more elastic, flexible texture than yellow corn. Combining the two doesn't just create a finer consistency, it also improves how well the dough holds together. Next, the mesa is forced through a narrow die to form a thin sheet. That sheet then passes through 2 metal rollers that shape it into a long, continuous ribbon of dough. A third roller cuts the ribbon into individual triangular nacho pieces. The dough ribbon runs through rollers with triangle-shaped cutting patterns on their surface. As the masa passes between them, the edges press cleanly through the sheet, punching out the signature Doritos triangles, what the plant refers to as nachos. At this speed, the line can produce around 500,000 snack pieces per minute, which works out to more than 30 million pieces every 24 hours. After the nacho pieces are cut and shaped, they move into an oven. But this isn't a standard oven, it's a modern 3-tier baking oven that runs at temperatures as high as 350 degrees Celsius. The nachos stay inside for only a few seconds before heading to the next step. The purpose here is to keep them from drying out too much during frying and to leave just the right amount of moisture in the chip. Once they exit the oven, the nachos cool down gradually on a slow-moving conveyor to bring the temperature down. But baking isn't the finish line. To get the signature color and crunch, the nachos still have to be fried. They're dropped into about 3,000 liters of canola oil heated to roughly 183 degrees Celsius, and they fry for just 55 seconds. This is the stage where Doritos develop those tiny surface bubbles, which are really small air pockets trapped inside the snack as it fries. After frying, a mesh conveyor lifts the chips out of the oil, helping them hit that golden color and ideal crispness. Excess oil is removed on a vibrating conveyor, then routed back to the fryer through a closed-loop system. That system helps control oil quality, slows oxidation, and keeps the oil fresher for longer. In the next step, the nachos move into a seasoning drum where they get coated with flavor. Large sacks of a secret seasoning blend, including cheddar cheese, parmesan, and signature spices, are dumped into a hopper and then fed into the drum to start the coating process. This mix isn't just cheese and spices. It also includes flavor boosters like MSG and preservatives that help extend the product's shelf life. To make sure the seasoning sticks evenly to the surface, a small amount of canola oil is lightly sprayed on, helping the powder bond and form that perfect uniform coating. Once seasoning is complete, the Doritos travel along a 100-foot conveyor so they can cool completely before moving into the packaging stage. Before Doritos are packaged, random samples are pulled for quality checks to make sure the product meets the highest standards. One key thing they measure is how much seasoning is sticking to each chip, making sure the coating is even and consistent. The final step in the production process is packaging. Once the Doritos are finished, they're fed into hoppers and routed to multiple packaging machines, getting them ready for the market. Each packaging machine is equipped with 14 head weighers to make sure every bag hits the exact target weight. As the nachos move into the measuring system, weighing buckets portion out the precise amount needed for each bag. Once the correct amount is reached, a trap door opens and the chips drop down. At the same time, the machine forms a continuous tube of plastic and foil film to create the bag. The moment the chips fall in, the system heat seals the bag and cuts it into individual packages. At the same time, the bottom seal for the next bag is formed to keep the line moving at high speed. Before the bag is fully sealed, nitrogen gas is flushed into the package. This pushes out oxygen to keep the Doritos from going stale or spoiling. It also creates a protective cushion so the chips don't get crushed during shipping. A large bag of Doritos holds roughly about 100 chips. Before cases are packed, workers double-check to make sure each box contains 8 bags. With a modern, high-speed line, this plant can produce and package up to 650,000 bags of Doritos per day, which adds up to more than 200 million bags per year. Now that you've seen the full process, can you guess how many corn kernels it takes to make one bag of Doritos? Drop your guess in the comments and see if you're right. Hit like if you enjoyed the video and share it with anyone who might be into this kind of behind-the-scenes factory stuff. To understand how instant noodles ended up on supermarket shelves today, we need to go back to Japan in the 1940s. After World War II, the country was struck by severe famine. Crops failed, and people lined up for hours just to buy a single bowl of hot noodles from street vendors. In those desperate times, ramen and gyoza, both made from surplus wheat flour, were considered revival foods, providing quick energy and helping people survive hunger. Yet the Japanese government at the time encouraged the use of imported American wheat to make bread, a food completely foreign to Japanese tradition. Witnessing this, a man named Momofuku Ando asked a simple question that would change the course of food history. Why not use wheat flour to make noodles instead? Ando began experimenting, determined to create a meal that was convenient, delicious, and could last a long time. The breakthrough came unexpectedly, right in his own kitchen. Watching his wife fry tempura, he realized the key was frying. The process removed all moisture from the noodles, leaving them crisp, shelf-stable, and ready to come back to life the moment hot water was added. From that discovery, the first block of instant noodles was born. Compact, lightweight, and full of potential. Ando knew that to succeed, his product had to be tasty, affordable, and easy to prepare. He achieved all three, selling each serving for just 29 cents. The result? Instant noodles quickly became a symbol of Japanese ingenuity and are now recognized as one of the greatest inventions of the 20th century. And the journey didn't stop there. This humble meal even made its way into space, where one astronaut famously smiled and said, "I really like it." Back to the present. Inside a modern instant noodle factory, the journey begins with the most basic ingredient, wheat flour. Truckloads of flour arrive and are pumped directly into massive silos for storage. When production starts, only the precise amount needed is transferred to the mixing area, ensuring freshness and consistent quality in every batch. Most of the flour is imported from Canada, known for its high-protein wheat, about 12% protein with only 0.2% ash content. In the industry, this is called go flour, the key ingredient that gives instant noodles their signature elasticity, chewiness, and naturally bright white color. A portion of the flour also comes from Australia, which produces a softer and lighter type of wheat. This helps fine-tune the noodle texture depending on the recipe. Not all flour is the same. Each region produces wheat with unique properties. Blending different varieties together is the secret behind the distinct flavor, texture, and chewiness that define each instant noodle brand. In the mixing area, everything begins with defining the desired characteristics of the noodle. The main ingredient, wheat flour, is poured into large industrial mixers that run continuously, processing several tons of flour each day. Here, the flour is combined with salt and chilled water. The water is cooled to very low temperatures to keep the dough stable and ensure higher quality noodles. The noodle's natural golden hue actually comes from vitamin B2, not from artificial coloring. Another crucial step is the addition of kansui, a traditional alkaline solution mixed into the brine. This solution raises the pH level, altering the protein structure in the flour and giving the noodles their distinct flavor and springy texture. This stage demands extreme precision. The moisture content must be controlled to the exact percentage, as even a slight deviation can cause the noodles to break, stick, or lose their shape during frying and drying. After mixing, the dough is allowed to rest for a set period so the gluten can relax, making the dough smoother, softer, and ready to be rolled into perfect noodle sheets. When the mixing process is complete, the dough is transferred to the lower level to begin the sheeting process. After resting for about 45 minutes to allow the gluten to stabilize, the dough enters a continuous rolling system. At the initial stage, the dough is still coarse and thick, about 2 inches thick. As it passes through a series of rotating steel rollers, the goal is to reduce the thickness gradually, never more than 30% per pass. With each roll, the dough becomes thinner, smoother, and more uniform. This process is carried out slowly and precisely, not just to flatten the dough, but to further develop the gluten structure, giving the noodles their ideal chewiness and elasticity. By the end, the dough reaches its final thickness of about 1/25 of an inch. Once the dough sheets are rolled to the ideal thinness, they're sent to the cutting machine, where razor-sharp, specially designed steel blades begin to transform the dough into noodles. Here, the cutting process not only shapes the noodles, but also creates the iconic wavy texture that defines instant noodles. The curliness or straightness of the noodles is precisely controlled by adjusting the pressure between the rollers and adding a special silicone belt. For example, to make tighter waves, the tension on the silicone belt is increased. This step is crucial. It's where the length, width, and shape of each noodle strand are determined, accurate down to the millimeter. Depending on the type of noodle being produced, the cutting machine can be fitted with different blade configurations. From fine blades for thin, springy ramen noodles to flat blades for wider noodles or cup-style varieties. Only a select few technicians are authorized to handle these blades, as their alignment requires exceptional precision and skill. After being cut into strands, The noodles move on to the hot water spraying line, a crucial step known as pre-steaming hydration. Here, fine nozzles gently mist the noodles with a uniform layer of hot water. The water is sprayed at around 160 degrees Fahrenheit, just enough to make the noodles more flexible without fully cooking them. As the starch inside the strands begins to swell and gelatinize, the noodles become more elastic and stable in shape. This process helps lock in the signature curly texture of instant noodles, preventing them from straightening or breaking during steaming. It also allows the noodles to lightly stick together at the edges, forming compact but non-sticky noodle blocks. From there, the continuous noodle sheet moves into the steaming chamber, where hot steam is injected at 210 to 220 degrees Fahrenheit for about 3 minutes. During this stage, the heat and moisture penetrate deep into the noodles, cooking them evenly from the outside in, enhancing both their flavor and chewy texture. Once the long, wavy noodle sheets have been hydrated and shaped, they're cut into equal portions known as noodle blocks. Each block is carefully placed into a metal mold that preserves its structure and wave pattern throughout the frying process. These molds are attached to a continuous oil conveyor, passing through a massive deep frying tank filled with high-temperature vegetable oil. Inside, the noodles are fried until crisp. Their moisture content drops to just 2 to 5%, low enough to prevent bacterial growth and allow the product to be stored for up to 12 months without preservatives. Frying gives the noodles their signature porous texture, allowing them to rehydrate evenly when soaked in hot water. It also enhances their flavor, aroma, and golden color. And yes, they're crunchy and delicious enough to eat straight out of the pack. After leaving the fryer, the noodle blocks pass through a vibration and hot air system that removes excess oil, keeping them light and dry. Finally, a blast of cool air rapidly brings down the temperature, locking in the crispness and preparing the noodles perfectly for the packaging stage. The steps you've seen so far are only half the journey before that packet of noodles reaches your bowl. The other half, and truly the soul of the dish, lies in the seasoning and soup packets, the elements that give each instant noodle brand its own unique identity and flavor. While the noodle blocks themselves might look similar across brands, it's the broth and seasoning that define their distinct character. A typical packet of instant noodles usually includes 3 main seasoning sachets. The base sauce packet. This determines the noodle's overall flavor profile, whether it's salty, sweet, rich, or spicy. The signature seasoning oil or paste, packed with the brand's unique flavorings and spices, ranging from beef stew, chicken, and mushroom, to Thai-style hot and sour or bold curry flavors. The dried vegetable mix. A colorful blend of green onions, carrots, corn, shrimp, chicken, or beef bits that have been dehydrated or freeze-dried to preserve their natural colors. These add bright shades of green, orange, and yellow, along with a fresh aroma that brings the bowl of noodles to life. To create the base sauce, the very soul of flavor in every packet of instant noodles, the factory begins by cooking a carefully measured blend inside massive stainless steel mixing tanks. Each ingredient is weighed with precision. Vegetable oil, salt, sugar, dry spices, minced onions, and finely ground chili powder. These are continuously stirred together to form a rich, balanced flavor base. A perfect harmony of spice, saltiness, sweetness, and savoriness. Once the mixture reaches uniform consistency, it is heated to around 190 degrees Fahrenheit, allowing all ingredients to fully dissolve while gently sterilizing the sauce to extend its shelf life. Next, the mixture undergoes high-pressure homogenization, which tightly binds oil and water molecules together, creating the sauce's signature smooth, creamy texture. For the signature sauce packets, each flavor follows its own unique recipe, and one of the most popular is the braised beef flavor. The journey begins with large beef leg bones delivered to the factory. Workers carefully inspect and sort them, removing any impurities before feeding them into industrial grinders, where the bones are crushed into small pieces about 1 to 2 inches long. The crushed bones are then loaded into high-pressure kettles, simmering at 250 to 265 degrees Fahrenheit for about 4 hours. The result is a rich, concentrated broth filled with gelatin, collagen, and natural beef fat, carrying that unmistakable slow-cooked aroma. Once the simmering is complete, the broth is carefully filtered and reduced, shrinking to just 20 to 30% of its original volume, creating a deep, robust flavor base. Next, the concentrated broth is pumped into large stainless steel mixing tanks, where the braised beef-based sauce is crafted. Refined vegetable oil is added first to help dissolve and carry the flavors, followed by salt, sugar, MSG, black pepper, garlic, ginger, and fried onions. The core seasonings that create a balanced, savory-sweet taste with a gentle heat. The mixture is heated to about 190 degrees Fahrenheit, then enriched with beef extract, natural flavorings, caramel color, and a touch of modified starch to achieve a smooth, glossy texture and an appetizing brown hue. Automated stirrers blend everything continuously for around 20 minutes, ensuring perfect consistency. Alongside the sauce and seasoning packets, the dried vegetable mix is what brings life and color to every bowl of noodles. The ingredients are carefully selected, usually green onions, carrots, sweet corn, garlic, chili, and mushrooms cut into small pieces. After being thoroughly washed and evenly sliced, the fresh vegetables are spread thinly on trays and sent into the drying system. In hot air drying, a gentle stream of warm air continuously flows over the vegetables, gradually removing moisture while keeping their shape and natural color. Then placed in a vacuum where water evaporates directly from solid to vapor. This process helps preserve nearly all the vitamins, minerals, and fresh flavor of the original ingredients. When consumers pour the dried vegetables into boiling water, a revival happens instantly. Within seconds, slices of carrot, kernels of corn, and bits of green onion expand and bloom back to their vibrant orange, yellow, and green. The noodles become not only more flavorful, but also more colorful and nutritionally balanced. Alongside traditional flavors, manufacturers have also developed special modern varieties, such as stir-fried noodles with tomato sauce, inspired by classic Italian pasta dishes. The process begins with massive drums of concentrated tomato paste, each weighing up to 1,500 pounds. These drums are lifted by mechanical arms and emptied into a high-capacity press, which extracts every bit of thick tomato concentrate inside. Next, water is added to reconstitute and thin the mixture, making it easier to pump through the factory's pipeline system. Within minutes, the tomato blend is transferred into a giant mixing tank capable of holding up to 1,300 gallons. Here, the tomato base is combined with precisely measured amounts of salt, vinegar, and sweeteners, creating a balanced, flavorful foundation. Meanwhile, in another large kettle, olive oil is heated and infused with onion, garlic, paprika, basil, oregano, black pepper, citric acid, and dried mint. This fragrant spice mix is lightly sautéed to release its aroma before being added to the main tomato blend. Once all the ingredients are combined, the mixture is stirred and gently heated for about 5 minutes, resulting in a smooth, rich tomato sauce with a distinctive herbal fragrance. So, what's your favorite instant noodle flavor? Share your go-to choice down below in the comments. Once the soup base and seasonings are ready, they are packed together with the noodle block, each serving containing the dried noodles, a soup powder packet, and a separate flavor or oil sachet. This packaging method preserves the full flavor and keeps every component fresh until it reaches your kitchen. After packaging, the noodles are shipped to stores all around the world, patiently waiting for that moment when someone pours in boiling water, bringing them back to life in a cloud of delicious steam. Thank you for watching all the way through. See you next time on another episode of Food Tech Today.